Alright everyone, so this lesson is going to be about circuits. It will be a little bit longer because there's a lot to talk about and to go over the problem, so bear with me as best you can if you need to take a break. That's what these videos are for, which is nice. You can pause it, come back to whenever you need to at your own time and leisure. That's kind of nice about them. But after this, we got one more topic to cover, but after this lesson, we'll have a lot of actually labs dealing with circuits before we cover the last one, and then we'll have the test in about 2 weeks-ish, the week after spring break, um, and then we'll be done with this chapter. So let's go on and talk about some circuits. All right, so when we talk about circuits, okay, we're gonna first draw mainly like circuit diagrams. So we're gonna actually draw a diagram of how this circuit looks, which remember we talk about electric circuits. That's the closed path through which electrons or electric charges or the electrons, remember, flow. And there are two types of circuits that we're going to talk about and use today, which is a series circuit and a parallel circuit. Now, before we talk about series and parallel, we're going to talk about circuit diagrams and everything that we go with that. So what a circuit diagram is, it's just a diagram of symbols to represent the parts of a circuit. So when we talk about circuits, it could be like a battery hooked up to a light bulb with a switch, like looking at this one at the bottom. Or it could even be like when you just look at how circuits are like in your electronics wired and things like that. But you would look at this diagram and then you write it in this equivalent layout, which is a circuit diagram. But what it includes is usually a source of electricity or energy and devices that are run by electric energy. So like the lamp, for example, in this thing. It usually has one or more paths depending upon what's going on. The arrows show the direction of the current, positive, negative, if we usually draw that. We won't usually see a lot of this for you guys, but just so you know that they do show that if they can. And the switches show places where the circuit can be open to. So when we draw a circuit diagram, uh, yeah, we're gonna have, if it has a switch, it's gonna be usually either open or closed, because like a switch is like a switch you would see when we turn the light off and on. Okay. If the switch is open, okay, that's an open circuit, which means the circuit is not complete, the current stops. So this is like saying like your lights are off, actually. While if you have a closed circuit, the switch is closed and the current is complete and charge can flow through it. So it doesn't mean because it's open, charges flow openly flowing through it. That's not what it means. It means the switch is actually open. While if it's closed, it means the switch is actually closed. There's a current going through it. But when we draw it, okay, let's say we look at just this first part, okay? Whenever you draw, you'll see lines, okay? For example, when we see lines like this, those just symbolize wires, okay? So that's like the wires connecting each thing to the next. Usually then you'll see what is a short or a long line followed by a short line in the middle of the wires. This is always usually going to be a battery or a cell. But most of the time it'll be a battery. This is where your power comes from, the battery of it, okay? This larger line symbolizes the positive end of the battery actually, and the smaller line represents the negative end of the battery. Okay? But that means battery if you see this symbol. The second part of, oh sorry, the next part was the switches. Okay, so a switch is like if you have this little dot here, and then you have a blank, and then there's another line coming up like this. Okay, that dot and line coming up, this is a switch area. So this is where your switch is actually occurring. This is what causes the circuit to open or close, okay? So this is an open switch right now. So this is open. If we had a closed switch, it would look something like this over here. So these are both switches, but one is open and this one is closed. The last part we'll mainly talk about for circuits are resistors, which are basically these guys, okay? They're just some squiggly lines essentially, but these are resistors. So this is where our ohms come from. So this is where we get our resistance from, our ohms if you remember. And remember the battery is where we get our volts from. Which, if you look at this, okay, we can actually use a circuit diagram to look at current usually, right? Remember, we're looking at Ohm's law. Remember, Ohm's law was looking at the voltage is equal to I, the current, times the resistance in ohms. Okay. This is what we'll be using actually for this whole part in this whole section. So let's move on and just talk about series circuits first. So a series circuit is when charge has only one path from the battery and returning to the battery. So there's only one straight path going from each end of the battery. There's nothing else between it. Okay. What this means is that if like one bulb burns out in a series circuit, I should say it becomes an open circuit and none of the elements can operate, for example. Okay. That's like saying, look at this bottom link. I have wires going from the positive and negative end to this battery, and I have the light bulbs connected to that single wire. Okay. That's what's called a series, is they're all in the same series line. Okay. Now, the thing about this is when you add light bulbs to a series circuit, okay, it actually decreases the current because the more light bulbs you add, okay, the more you're increasing resistance among the electrons flowing, which means each light bulb will actually burn less brightly or shine less brightly compared to one light bulb because they're in a series circuit, because they're all in the same line. So when we use series circuits, okay, again, the current is the same throughout. The total voltage, if you have more than one voltage, for example, is the sum of the individual voltages. So what do I mean by that? Like say like if you have two batteries, like say I have one battery and I have two batteries. Okay. Saying if this was like 2 volts and this was 3 volts, okay, the total voltage, like if I want to get V sub T, would just be 2 plus 3 equals 5 volts. Okay. So in a series circuit, the total voltage is the sum of the individuals. But resistance, this where it gets tricky. The total resistance is the sum of the individual resistances. So that's like saying if I have one resistor and two resistors in something, okay? Let's say this is 3 ohms and this is 5 ohms, okay? The total resistance then is going to be equal to, we'll call this R1, R2. It's just going to be R1 plus R2, which gives you 3 plus 5. That means the total resistance is going to be 8 ohms. Okay, so series are easy. They always add up to get the total amount. So let's see how we can use that first. All right, so let's look at a general circuit diagram just so we remember how to find current. Ooh, that got lighter. Okay, let's just say I have this resistor and it's equal to 6 ohms. And I have this battery, which is equal to 12 volts. I want to figure out what the current is, I. So this is where we have to use Ohm's law. Voltage equals current I times resistance. So we have the voltage, there's only one of them, 12 volts. We're looking for I, and we know the resistance is just one resistor, so it's 6 ohms. So you just got to solve for I. So just divide 6 over, and you'll get I to be 2. Remember, this is going to be measured in amps, A. That's how we measure current. So that's just a simple way of how to find current. Well, let's look at a series circuit now where we have more than one resistor. So let's say we have a battery again. But now I have one resistor and two resistors in this circuit. Say the battery is now 24 volts. This resistor, let's call it R1, is equal to 12 ohms. Let's call this R2. That's equal to 6 ohms. Okay. So now we still want to find out what the current of this circuit is, I. So again, we're still using V, whoops, equals I times R. But we have two resistors, so we need to use the total resistance in this equation. So this equation will always deal with the totals, not just one or two. So we first need to find R sub T, which remember in a series, it's just the sum of the individual resistors. So it'll be R1 plus R2, which will give us 12 plus 6. So the total resistance is 18 ohms. And now we'll use this to plug into our equation. So we have our voltage, 24 volts equals I times 18 ohms. Divide 18 over by 24. 24 divided by 18 is approximately 1.33 amps. Okay, so that's how you would do it in a series. So let's move on. Sorry, this is going to take, like I said, we're at 11 minutes, guys. So if you need to take a break, pause in between a series, and then parallel, come back to it later, you can. Let's move on. Now let's talk about parallel last. This will be the last thing. So what the parallel circuit is now an electric circuit with two or more paths through which charges can flow from the battery, returning to the battery. So it's like saying, look at this battery light diagram over here. You have the wire starting at the positive end. It goes to one light bulb, okay? But now the light bulb isn't connected to the same line right now on the same side. So like if you look at before, let me go back. You see the wire went from one end of the light bulb to the next light bulb, to the next. But now it's connected on both sides of the wire. So now the wire isn't going through the light bulb, it's on the sides of it essentially. And then it goes to a next one, and then it comes back around. So this is what's going to be called a parallel circuit, which this is exactly actually what happens in your household, okay? Everything here is a parallel circuit with how everything's connected, because parallel circuits allow, if one thing stops functioning, charge still flows, compared to a series where if one thing stops functioning, the whole thing doesn't function. So that's what allows parallel circuits to be used more often, because if, like, let's say this light bulb burnt out, this light bulb will still work. Okay. While if you had one light bulb burn out in a series, none of the light bulbs would actually light because they're in the same line of charge. So that's what makes parallel circuits more common in like households. So again, when we look at how the voltage and current compare into resistance, voltage is the same throughout all voltage elements like a series. And the current is still found by Ohm's law. But now the total resistance is going to be different. Now the total resistance is the sum of the reciprocals. Remember, your reciprocal is you're taking 1 over that resistance, remember, so whatever the R is, of each of the components, so each of the resistors, and you take the reciprocal of the sum. So what that is saying is, let's say I have two resistors again. Oops, that's a series, not a parallel. Let's say this is my parallel circuit. This is how parallels are drawn. They're a parallel. Let's say this is R1, this is R2. Now you're going to take the reciprocal of each of them. So I'm going to take 1 over R1, and you're still taking the sum of them. So it's plus 1 over R2 is going to be equal to now 1 over the reciprocal of the total. So now you're just inversing everything compared to a series. So remember, in a series, it was just like RT equals R1 plus R2. A parallel, it's just all 1 over those instead. So let's look and see how we can solve it now for a parallel circuit. Skip that one. Oh, where'd my blank page go? Yeah, I'll just do it at the bottom there. I thought I had a blank page at the end of this. Let's just do it here then. So let's say we'll look at two examples. Say here's my battery, 12 volts. there is one resistor and there is two resistors. So there's two resistors in here. Let's call this R1. Let's call this R2. And let's say R1 is 6 ohms and R2 is 4 ohms. So remember, we're still going to find what the current is in this circuit, what I is. We're still using Ohm's law. But again, we need to find the total resistance to plug in if we have more than one resistor always. So remember, we're going to use that 1 over RT is equal to 1 over the first resistor plus the second resistor, etc., with however many resistors you have. So we're going to take 1 over RT, what we're looking for, equal to 1 over the first resistor, which is going to be 6 ohms, plus 1 over the second resistor, 4. So we're just going to do that. We're going to get 1 over RT equal to, I didn't calculate this one today. You should get 5/12, which if you want to get RT, you'll just flip this whole thing. So now RT is just going to be 12 over 5, or approximately 2.4 ohms is going to be our RT. So now we can plug in this to our Ohm's law. So we have our voltage, 12 volts from our one battery, equal to I, what we're finding, times 2.4 ohms, divide 2.4 over, and we'll get the current of this to be approximately 5 amps. And there we go. All right, let's do one more, and then we'll be good. So now let's look at one with just 3 resistors. So same concept, but 3. Here's my battery. Let's say it's 30 volts. Here's my first resistor. Here's my second resistor. And here's my third one. So now I have 3. And they're all in parallel. So let's say this is R1, which is equal to, in this case, let's say 5 ohms. This is R2, which is equal to 6 ohms. And let's call this one R3, which is 10 ohms. So again, we're using V equals I times R to find the current, I. Let's find the total resistance first. So we'll do 1 over RT equals 1 over 5, our first resistor, plus 1 over 6, our second resistor, plus 1 over 10, our third resistor. So once we add all those together, we should get 7/15 for 1 equal to 1 over RT. Remember, we want to find what RT is, so we'll just flip it, because we want to flip this to get RT. So it'll be 15/7 ohms. I'm going to leave it as that for right now, just to make it easier. So now we can plug in, remember this, into our Ohm's law equation. So we have the voltage from our battery, 30 volts, equal to I times 15/7 ohms, divided over, and then we'll get the current of this circuit to be 14 amps. Okay. That's pretty much it. So, took a little bit longer, like I said, this one, but the next couple of labs and things will do a lot with circuits and everything, and circuits are going to be an important part of how you actually understand electricity too. So again, like always, guys, if you have any questions, let me know.